Okay, guys, so today what we're going to be doing is we're going to be writing equations of parabolas. Now, we've already spent a little time this year writing equations of other graphs. Like, for example, the first equation I taught you to write was the equation of a circle. Remember the two things you needed? What were the two things you needed in order to write the equation of a circle? The center and the radius. Okay, so you needed two things to write the equation of a circle. Then we reviewed something we've done a lot of times, writing the equation of a line. And what were the two things you needed to write the equation of a line? Slope and a point. Slope and a point. Okay, so today we're going to add to that, writing the equation of a parabola or a quadratic. And to do that, you need the vertex and a point. Okay, so we're going to be writing these in standard form or vertex form because we're given the vertex, so it's useful. So we will be writing the equation in this form. F of x equals a times quantity x minus h squared plus k. And in order to write these equations, we need the vertex, which we will be replacing the hk in the equation, this number and this number, with our vertex. So we'll just plug those two values into our formula. And then some random point on the parabola, it might be an x-intercept, it might be a y-intercept, it might just be some random point. And that'll be our x and y, in other words, f of x. And we will plug them in to these two positions here. So what's the only thing missing from this equation? The a. And so that's what we'll be doing. We'll be plugging in our vertex coordinates, our other points coordinates, and solving the equation for a so that we can figure out what kind of stretch or compression does this parabola have? Does it open up? Does it open down? Like that. So here's our very simple instructions. Plug the vertex and the point into standard form. I'm going to write standard form and then in parentheses EULA into the standard formula, which is standard form, right? And solve for a. And that's all we need. Then we will write the equation, we'll plug in the a and the vertex, and then we'll have the equation of the parabola. Now, typically, you know, when you see the equation of a parabola, it'll look something like this. Don't write it down. I'm just writing, so you're thinking. It'll look something like this. Right? This is what we practiced writing a couple days ago. Our equations would always look like this. You'd have an f of x, you'd have an x, you'd have your vertical stretch, compression, reflection, and your vertex. That's what you'd have. So this is what we're shooting for, having these three positions in our formula filled out. Okay? So let's start with, I'm going to pick up my red pen here, the vertex. It says find the standard equation of this parabola. So here's my vertex right here. So my 4 is my h and my -1 is my k. That's useful because I know where I'm going to plug that in. Then I'm going to switch to my green pen and I'm going to come grab up this point right here. And so this is point P, and 0 is my x and 1 is my f of x. So I have all four coordinates ready to be plugged into standard form. Then we'll just solve it for a and figure out what our compression or stretch is. I think it's got a compression. Don't you think? That's a pretty wide parabola. So it looks like it's got a compression. It's probably going to be a fraction. Let's take a look. So the first time I do this, I'm going to go ahead and write out the equation first. and then I'm going to replace, or the formula, and then I'll replace them with numbers. You can just watch if you want. So f of x is equal to a times quantity, x minus h, quantity squared, plus k. I'll fix that h up a little bit. Okay, and then I'm going to do it again. Now watch. This time, I'm going to use my colored pens to fill in my I'm going to fill in there and there and there and there. So I'm just going to write all of my other stuff in pen real quick. A quantity, I'm going to fill in the x minus, I want that, the squared and the plus. All right, so those are all the things that I'm not replacing in my formula. They all go there. I'm going to go ahead and put my f of x, which is 1 for f of x. And then for x, I'm going to put 0. So that's my point. I'm plugging in my point, my x and f of x. Now I'm going to switch to my red pen so that I can plug in my vertex. So -4, right? So -4 and -1. Just plugging in my h and k. That's not so bad, right? So I'm going to simplify this real quick here. -4 squared. I'm going to rewrite. All right, so 1 equals a times 16, yeah, minus 1. And we're going to solve for a. So I'll add 1. So 2 equals, I'm going to rearrange that to 16 times a instead of a times 16 because that feels more comfortable. Divide by 16, of course. And simplify because I am a mathematician. Excuse me, 1/8. That's a major compression of the graph. Okay, so now I know what a is. I'm going to go back and write the equation of my line, of my parabola. So f of x is equal to my a, so I'm going to plug that in right there, 1/8 times x minus, what's my vertex? 4, quantity squared, minus 1. And there you have it, my friends. You have written your first equation of a parabola, given from points. It's probably most of your first time doing that. I don't know. Maybe if you came from a different school, you maybe have done this before. But I know I didn't teach this last year in math analysis. Okay. So let's take a look at this next one. I think you could probably do it without me. I'm just going to separate my page a little bit here. But before you tackle this problem, I just want to clarify something. Because I noticed today when I was teaching this earlier that a couple people tried to choose this point right here, which is right there. And I'm thinking, do you know exactly 2 point what? I'm thinking you don't. So I'm thinking if you were to guess, you'd probably be more likely to be wrong than right. So you need to make sure that you're actually picking a value that is obviously the value, like this one right here, 1, 0. You could use that as your point, or maybe this 0 over here, which is -5, 0. Either one would work, but make sure when you're picking values that you are 100% sure of that, the coordinates of that value, of that point. So there's your HK, and here's your f of x, or if you want to, you could use -5, 0 instead. I'd like to see you give it a try. I'm going to pause the video and have you try it, and then come back when you've got an answer. Okay, so you should have gotten a equals -4/9. And then your equation is f of x equals -4/9 times quantity x minus -2 or plus 2, quantity squared plus 4. And there's the equation of your parabola. Down here at the bottom, you're doing a little more of the same thing. You're finding the standard equation of parabola that has a vertical axis. That's important because then that means your parabola opens up or down because its axis of symmetry is vertical. It doesn't open left or right. We don't want that. And satisfies the given conditions. So with the first one, pretty similar to the problems that we've been working on, right? You got a vertex and a point. So your vertex, there's your HK, and your point is your x f of x. And you plug those into the standard form. So I'm going to put my information in real quick and then plug in my values. So 25 equals A times 3 minus 0 quantity squared plus negative 2. Then we'll simplify that real quick. That's 3, right? Okay, so that's 25 equals, can I just square 3? 9A minus 2. We'll add 2 to both sides. 27 equals 9A, so A equals 3. You okay with that? It's 27 divided by 9. Then we write the equation, replacing the A with a 3, and then plugging our vertex back in. I do want to caution you that as your math teacher, if you were to give this solution to me, I would mark off 1/4 point because it is not simplified. I would like to see the final version of 3x squared minus 2. But I think it's important for you to make a connection between those two things, because when you see an equation that looks like this, now you know that your vertex is at 0 and whatever your constant is. So real quick, just as an extension, what if I said this was the equation of your parabola here, and I asked, what's the vertex of this parabola? 0, negative 5. 0, negative 2. That 0, it's there, you just can't see it. Could just do this. There it is. 0, negative 5. Okay, just pointing that out as something to add to what you already know. All right, let's take a look at this next one. Do we have enough information to write the equation of this next parabola? Yes. Okay, so we have an HK. All right, that's good. What's our point over here? We have a y-x intercept, but it's only one coordinate. What am I going to do? Because the next intercept, that means your y is 0. Absolutely. So there's your x, f of x. So we'll quickly plug those in. I'm going to just do my other color here. A times minus quantity squared plus, and then I'm going to go plug in my 0 and my 2 and my 3 and my 5 and simplify. So that's negative 1 quantity squared, which is 1 squared, right? Or 1. So 0 equals A plus 5. That's a nice one. Minus 5. So A equals negative 5, right? That one went quick. So we write our equation, f of x is equal to a negative 5 times quantity, x minus 3 quantity squared plus 5. Just re-plugging in your vertex and plugging in your A. So not too bad, not too big of a brain drain, plugging in points and finding A. Let's take a look at this last problem. Now, this last problem, it's not quite as obvious you're not just handed, here's your 2 points, plug them in. Here's what you're given. Your x-intercepts are at negative 3 and 5. And the highest point, what does that indicate, the highest point? The maximum, which is your vertex, right? The highest point has a y coordinates of 4. So here's what I know. On my vertex, my y is 4, but I don't know what my x is. But I have been given 2 other clues to help me out. So maybe I'll just draw a little visual here. You need a drink? Go get a drink. Go get a drink. At negative 3 and 5. All right, so there are my zeros. Where would my vertex be located? In the middle of them? It has to be on the line of symmetry. And doesn't the line of symmetry have to be right center between all of the points that are not on the vertex, right? So could we just find the midpoint between these two x's? Because we already know it's going to be somewhere up here at 4, right? Because it says the y coordinate's 4. So I think we could just take -3 plus 5 and cut it in half and find the midpoint between our x's. Yeah? So I think 1, 4. And that totally makes sense, because how far is 1 from 5? And how far is 1 from -3? Perfect. Okay, so dead center right there, there's your vertex. So here's your HK. And then you have 2 other points you can work off of. Which one do you want? 5, 0 or -3, 0? All right, we're going to go with 5, 0 because you spoke louder. So there's your point, and there's your vertex. So you guys give it a try. I'll pause the video, give it a try, and then come back and see how you did. Okay, so there you go. You should have gotten f of x equals -1/4, quantity x minus 1 squared plus 4. Homework is on Canvas, 2.2c, due on Monday.